shear. Check for shear. For this one we have one formula, that is tau v is equal to vu by bd. Tau v is equal to vu by bd. This is in the IS Focus 2000 clause 40.1 in page number 72. You can get this formula. Okay, so substitute here values. You will get vu. Vu you have already calculated, that is see here vu is 26.69 kilonewton. So substitute there 26.69 kilonewton. Kilo means 10 power 3 newton divided by B is always 1000 into D is 150. You will get the value 0.178 Newton per mm square. Okay, this is in mm, this is in mm square. This is kilonewton. Kilo means 10 power 3, remains Newton. Newton per mm. But in slabs you need to multiply tau c by k. Therefore you need to compare tau c with tau c k. You need to compare tau v with tau c, but in slab you need to compare tau v with tau c k for slabs. Tau c k. For other structural elements like beams and all, you have to compare with tau c. So now how to get tau c k means, in page number 73 you have one formula, one table you have. In that one you will get the value of tau c, then you multiply k value, you will get tau c k. Now how to get the tau c k value? For that one, first in table, in column number 1 we have percentage of steel PT is equal to 100 AST provided. Here it is provided, not required. AST provided, here it is provided, not required. Okay, because what we have provided, for that provided steel, whether it is again safe against shear, that we are calculating. Required we are not calculating. Provided we are calculating. Therefore we have to use provided here. Therefore substitute 100 into AST provided is 549.7 divided by is B into 1000 into 150. You will get 0.36% of steel. Okay. Now in the table, left side you have percentage of steel PT, right side you have tau c. Okay, here in left side you have value for 0.25 and you have value for 0.50, but you don't know for 0.36. You got 0.36 here. You need to calculate what is the tau c value for 0.36. So for 0.25 you have 0.36, and for 0.36 you don't know that value, and for 0.5 it is 0.48. So tau c value you need to find out by using interpolation. This is of the form like A, B, C, X, Y, Z. Okay, here you want Y. So this Y can be written as Y is equal to X plus, okay, Z minus Y divided by C minus A into B minus A. If you substitute to this formula, you will get what is the value of Y. Okay. Now this is of the form, this one only, ABC XYZ, ABC XYZ. We want Y value, we want Y value. According to this formula, substitute here, you will get the value of Y. So tau c, Y is equal to tau c is equal to X. X is 0.36 plus numerator Z minus Y. Z minus Y. Sorry, it is Z minus X. Okay. Z minus X. Yes, it is Z minus X. Z minus X 0.48 minus 0.36 divided by C minus A. C minus A. C minus A. 0.50 minus 0.25. into b minus a. B minus a is 0.36 minus 0.25. B minus a. B minus a is 0.36 minus 0.25. Substitute here, calculate, we will get tau c value is 0.413 Newton per mm square. Our obtained value is right or wrong? So this should be in between these two values. 0.41 is less than 0.48, more than 0.36. Therefore, it is correct. That means whatever the value you got is correct. Now we need to find out tau c k. Okay, tau c k only for the slabs. Okay, other like beams you have to use only tau c. Now tau c k, what is the value of k? So tau c is 0.413 into k value. What is where we will get the value of k? In clause, I think in page number 40.2.1.1, you will get the value of k in the table corresponding to the depth, capital depth, that is overall depth, not small depth, overall depth. You will get the value of k. Again here is in the form of ABC XYZ. This is only, so we have d values and k value. So for d value 150 and 170, 150 we have 1.3 and 175 you have 1.25, but we don't know value 170. That we need to calculate. Again here you have to do interpolation like this only. So k is equal to x plus, this is x 1.3 plus numerator z minus x is 1.25 minus 1.3 divided by c minus c, that is 175 minus 150 into b minus a. B minus a is 170 minus 150. Okay, here k value if you calculate by calculator, you will get k value as 1.26 you will get. Okay, that means whether this is between these two, yes, 1.25 greater, 1.3 lesser, 1.26 correct. Therefore substitute here 0.413 into 1.26. Tau ck we will get 0.52 Newton per mm square. Okay, next we need to compare tau ck with tau v. Okay, now by comparing these two values, tau ck and tau v, we got tau ck is tau v. If tau c is greater than tau v, therefore the designed slab is safe against shear. That means she is safe against shear. Next we need to check for the deflection. Now next step, almost last step, check for deflection. For check for deflection also we have, so our next step is to find out check for deflection. Here we need to calculate L by D max and L by D provided. We calculate both the values and compare at last. Now we will find what is the L by D max. For L by D max we have one formula. L by D max is equal to L by D basic into constant KT, constant KC and constant KF. This is the constant if it is a flange section, This is a constant if it is a compression member. If it is a tension member, KT will come. So now it is there is no doubly reinforced, there is no flange section, therefore it is only KT value will come, both will become 1 here. Okay. So now where to find L by D basics? This L by D basics you will get from the page number 37 in IS 456. Page number 37. Page number 37 in clause 23 you will get the value in point A. You can see basic values of span to effective depth. Span to effective depth, L by D only. Basic values means L by D basic. Here he has given for cantilever it is 7, simply supported 20, continuous 26. Here our problem is simply supported, therefore 20 value we should consider for L by D basic. Substitute here L by D will be 20 because simply supported into KT. KT again we need to take it from IS 456 2000 only in page number 38. Page number 38, figure 4. Figure 4, modification factor for tension reinforcement. Okay, in that one graph is there. In that one, X is percentage of steel, that is percentage of steel, that is PT. Here you will get KT. Okay, but here in order to calculate you have graph like this. Here for FS value you have to see. So now what is the FS? Again the formula for Fs is there only, it is given. Fs is equal to in page number 38 only you have this formula. Fs is equal to 0.58 into Fy into area of steel provided, required divided by provided by AST required divided by AST provided. Okay, here we need to check for AST required, AST provided only for main steel reinforcement, only for main steel reinforcement. Okay, 0.58, Fy is 415, AST provided we need to take, we should not take distribution AST required, AST provided, we should take main reinforcement AST required and AST provided. Main reinforcement AST required, AST provided. AST required is 481, AST provided is 549.7. So 481 divided by 549.7. If you calculate this one Fs value, you will get 210. Okay. So now percentage of steel PT we have already calculated. PT from this formula we have already calculated. PT value is 0.36. That means, so in this IS 456 you can see there like graph. Here it is PT, here it is 0.4, 0.8, 1.0, like 1.2, sorry 1.2, 0.4, 0.8, 1.2. Okay, and corresponding we have 0.4, 0.8, 0.8, 1.2, 1.6, like this we have. And Fs value also we have this here 120, 145, 190, 240, everything is there. But our Fs is 210. 210 is near to Fs is equal to 190 curve. Fs is equal to 190 curve. That means, and here another curve is there, Fs is equal to 240. That means our Fs for 210 will come between these two. Somewhere here between these two our curve will come. So now what is Pt? Pt we have got from that equation is 0.36. 0.36 somewhere near to 0.4 here only. So if you go 0. Kt value as here somewhere here it will come. Therefore we can take Kt value as 1.65. You go to IS 456 page number 38 in figure 4, you can easily get the idea about this one. Okay, you will get Kt is equal to 1.65. You substitute your Kt 1.65 into 1 into 1. So you will get L by D maximum value as 33. L by D max. So now we need to calculate what is L by D provided. L by D provided means what we are providing. L by D provided is equal to length we are providing is here 3.65 L we are providing, that is 3.65 meter divided by small d is 150 mm, that in meter it is 0.15. We will get the value 24.3. Now compare L by D provided and L by D max. L by D max is 33, L by D provided is 30. Therefore L by D max is greater than L by D provided. Whether it is safe or not safe? Actually it is safe. Why? Because maximum value should be 33. Maximum deflection is 33, but our deflection value, our provided value is less than maximum. Maximum value you should get maximum is 30, but you have got 24.3, therefore it is safe. More than this, if it is there, that would be unsafe. Now it is less than the maximum value, therefore safe against deflection. That means it is safe against shear, safe against deflection, safe against depth also. That means everything is clear. Now your slab is reinforcement details. Reinforcement details. Now we need to draw figure. Because it is a one-way slab, that means main reinforcement should be provided in the shorter span, and along across span you should provide distribution reinforcement. Now I will write the plan. Subscribe to my channel. Click the bell icon for more videos.